Hi guys, good morning or good afternoon or good evening. This session we will see about that in Esprit. It's a fifth session about the pocket milling and what are the functions available in the pocket milling will be covered on this. So let's move into the file. So this is our today's exercise file. It's just loading up. Yeah, this is our simple block with one hexagon slot, which is used to we are going to generate an program or pocketing for this. So first of all, I have just generated an futures as an pocket, and I'm just going for, after selecting the pocket, I'm just going for machining, and from machining I'm just going to solid mill traditionals. From there, either I'm just going to pocketing, or you can go to solid mill traditional and you can call the toolbar and you can go with second option. Okay, something yeah, see here, pocketing. So this is the pocketing options which is available on our Esprit. So if you see the first option, it will says that which pocket, either you have an 2 to 3 pockets, you can use this. We will see in this option later. And next is rough. It is an for what is the parameters to use on roughing parameters. So there is an feeds, first is a cut speed, which is an in RPM, and second is a feed rate, and third is in eject. You mean we can say that plunge feed rate, and this is our maximum feed rate. And I'm just turned off the use of speed and feed from a knowledge base, and I'm just going with the step over of 7.15% 50 percentage, but the dia of the cutter is around I think 14.5. so why 15 mm cutter, so why it is coming 7.5. And stock allowance on walls, I don't want the stock, but I need in the floor I need some stock, so I'm just leaving as 0.5. and maximum width, and this is for the corner radius formation and ramp angle adjustments, so I just leave it as it is. And for the floor finishing, wall finishing, I'm just using 2000 rpm and 128 feet per rate. And next is floor finish, also I'm just a little bit increased something, and I just going for links and checking that clearance and return plane. Yeah, it should be in partial depth or full clearance or initial clearance. I will just give full clearance, and I just click OK or apply and exit. See, I think you will don't see that toolpath because it's in gray color. I will show you here in simulation. Okay, so you want anything to add? Yeah, I will check all the status displays. I will give this as an green will be our stock, and yeah, so it is a missing thing. This is how our material removal rate will be happen in this part. If you see here, if you see here, it is an ramp program. It will be in the some angle inclination. The cutter will start removing the materials. So I will just speed up some of the things. This is how you will get that physical part will be machined in that when you input this program. Yes, little bit speed at that. Okay, we got something. I hope it is going to complete, and it is in our final pass, for which we have given as an wall finish. It's running up, and it is our floor finish. Okay, it's also going around 10 to 20 passes. We can stringent that either, or we can just remove that finishes. It will be going in the point of 0.1 or 0.05. I have given like that. So if you want, you can give as an finishing stock as an 1 at once. Yeah, it's why it's taking some time, I think. Yeah, now only it's taking for removal. Yeah, it's completed. So next, if you want to see that what is the slug rate, you can by at the time of things, you can just click here and to press. It will show how many material has been removed and what is the removal rates, like that. And the simulation has been completed. Now next is we have to generate a program for this. So select that excuse me, and select that program and go for file machining by right clicking, and you can, from there you can get your NC code. It calls for a post processor. I will just go with browse. I don't have the post processor. Yeah, I am just going for my which machine. I will just take some programs for my post mills. Masaka or Makino. Yeah, I will take for V655 and click OK. And it asks for where the program should be kept. I just fixed my directory, and yeah, this is our program. It started with O0001, and these are our codes G00, G91 for this machine. It's going around 7,500 lines. So if we done in properly, we can remove around 10 to 15,000 lines. We can eliminate it, and so this is completed, and this program is a final output of this part, and I'm just saving that file. And next I'm just going for taking my Excel reports. So I will just go for file and collect my create Excel report, or you can say that I need a report, create reports. And in this there are 5 categories. One is milling detailed and another one is milling summary. I will just go with milling detailed. In that option I will just go with any options there. I will just book it out. Yeah, that's it. I just click and create reports. It will run and collect those details, and the PDF will be opening. It's processing time. So after this completion it will open. Okay, and it is my reports generated location, so it's shown. And if you see here, it is my report from the Esprit. If you see, I just used 15 cutter end mill, and that it is has an tool operations and speed feeds. What is the average I'm just used, and what is the cycle time, and what is the commands I have given in this program. And the next page, it is my operation details. It will say about where is my coordinates, and what is my work offsets, and what is the cycle time, and what is the rapid length and feed length. Those details will be fetched here. And what is the tool details, either tool is used insert type, or what are the spec and spindle direction and coolant length. And it is my tool list. If you have 20 tools, it will be plotted one first, second, third and fourth based on that operation or things. And it is tool list, and it is my tool details. I think there is no difference. If you have given any commands only, it will be changed in that tool details. And if you see the milling summary report, it is only the first page will be your output. Only that cumulative cycle time and what is the tool used, it will be only fetched in. And you have another option in this. You can exit here and you can go for file and go to Excel, create Excel report. In this you can give that names as for your required. I will just give it as report title as pocketing. I have short, it says 2. If you have a company name, for example, I am just saying designer CVE, and I have the logo. You can just fetch it here. I just not put it. And for details, you can put it as extrusion, and you can input what is the size, length and width and those things. And just now clicking on 150. This will be 120 and height will be 20 mm. And just input it, and these are my header details. And I will check all the things, and process list, it is not generated. So let's delete that. things can be, whatever things you require you can do that. And if you need the barcode also you can put it inside. If you have your tools, for the tools you need the barcode, you can enable here, or you don't want to enable. I just give the file location and save a copy as PDF also, and I just click OK. See if it will run some time for process, and it will share the tool reports. It is where the X and Y offsets and all the things will be collected from here. So whenever my suggestion is, if you go with an Excel report, it will give you a complete study of your CAM, the product which you developed in the CAM, and you can also optionally call it this as in PDF. Okay, so I just close it, and this is my Excel. You see which are the inputs we have given on that reports which I just taken, and it has an only one tool operation, one operation only, and it says that what is the feed rate is given, and what is the speed, what is the diameter used, what is the RPM, and those details will be detailedly given in this. And the same thing which we have seen before in the tool list, and it is our coordinates where and XYZ, and where we have taken that offset to take an work offsets, and this is our post processor details, and this is our time chart. Okay, so it is given in seconds, so when we divide by 60 we will get 241 minutes, that means 4 hours. The work coordinate will be taking up to in that thing, so it has given something. So next is tool times. You see only one tool it goes through. When we do multiple tools, it will give you a chart in the bar chart, so we can able to study what is then a maximum occupying tool, and this is our layer, and that's all. Anyway, this report will be very helpful for you to analyze and improve your cycle time, and then I am just saving the files. Anyway, thank you for watching, and please subscribe our channel and support us. Thank you.